Hello and welcome to today's lesson, a review of survey and experimental design. So today we're just looking at the really big ideas for these two topic areas and how they will be represented on AP free response questions. Okay, now the structure of today's lesson is basically kind of a question and answer. So we're going to ask a question, you want to pause real quick, think about your answer to it, and then as I go through, I'll reveal the answers. Okay, so I'll give a small pause, but not as much pause as I would in a traditional class. Okay, so you definitely want to stop and try to answer these questions on yourself, and then wait for the reveal to see how you did. Okay, so our first question that we want to think about in this scenario is what's the difference between a survey and an experiment? Okay, when we're looking at the difference between a survey and an experiment, it is an experiment has a treatment that is being imposed on the individual being tested, whether it's a subject for a human or an experimental unit for something else. Okay, now, there is a third type of data collection that we can look at in the scenario, and it is distinguished between the other two. That third type is an observational study, where you're observing and recording. It's not technically a survey, where you're handing out a survey questionnaire, bringing people in for a survey. You're just observing and recording overall. But it is an additional method for collecting data overall. Okay. Then the next thing we want to look at, what is the difference in the results conclusions that we can come up with when we're talking about an experiment and a survey or an observational study? Okay, so what's the difference in the conclusions that we can make? Okay, and what we want to understand is if it's a survey or an observational study, all we can do is find a correlation between the variables, okay, that these two things show a relationship between them. Causation truly needs an experiment to be able to prove that process as we work through. Now, as we kind of move through our topic, okay, what process does both a survey and an experiment have in common? Okay, sorry, I'm trying to get the mic to work a little bit better here. They both have a simple random sample in common. If you're wanting to conduct a proper survey, or if you are wanting to conduct a proper experiment, okay, they both need / require a simple random sample. Okay, now, one thing that is done in a lot of free response questions is they'll ask you to describe the process for conducting a random sample or a simple random sample. Okay, now, in your answer, you want to have a description of the population. Okay, so you're talking about the entire group that you're working with. And then you also have to describe a random process. So option 1, pulling names out of a hat. Okay, one thing that you want to describe is that you list all of the individuals on separate sheets of paper, put them in a hat, and draw the names randomly out of the hat. So you do have to talk about the random selection. Okay, it does have to be a part of your answer. And it's also important to describe your group. What is the population that you're working with to select that sample from? Okay, option number 2, okay, the more true statistical method is number all the individuals in your group from 1 to whatever your population value is, and then use a random number generator to select whatever you're looking for size-wise. Select 100, select 30 from your group overall. Okay, but remember, you want to talk about the population and either you're numbering them or you're putting all of their names in a hat, and then your random process. You're randomly selecting from the hat, or you're using a random number generator to select the values. Okay, now, when we're talking about experiments or surveys, we always have to think about the bias that can be introduced in that situation. And in general terms, bias is just something that affects the outcome of an experiment. Okay, voluntary response is a type of bias, and that's the idea of an opt-in. People are choosing to respond to that survey, and when you do that, it's going to overrepresent the extreme values. You're going to get your highs and your lows, but the people in the middle aren't necessarily going to respond as much overall. Okay, notice that that's the opt-in versus non-response, which is an opt-out. These people have been selected for the survey or chosen for the experiment, but they're choosing not to respond or not to participate. Okay, so that's really important, the fact that it is an opt-out. And people often misconstrue these two terms and talk about a non-response as a voluntary response process. Okay, but people volunteer to response is the opt-in versus the non-response, which is an opt-out scenario. Okay, we've got hidden and response bias. Okay, these are both with respect to either the experiment or the survey. The hidden bias is on the experimenter side. It's most often the wording of the question. You know, a leading wording of a question would be a hidden bias. Okay, it's not shown, but it would affect the outcome overall. And then we've got response bias, which is from, you know, the survey individual or the experimental subject not giving a truthful response based on either illegal activity or something that they don't want to admit to an individual process-wise. Okay, last type of bias that we want to understand is undercoverage. Undercoverage can happen in a number of ways. It can be a situation where people just are not able to be reached. Okay, or based on your simple random sample, you might not cover all of the groups from an individual population. Okay, so it's groups being underrepresented based on the process used. Okay, so a simple random sample can introduce bias because if we're sampling 100 seniors from MHS, there's a chance that all 100 could be seniors. Okay, a simple random sample could do that, and we just want to understand that that could be an undercoverage situation. Okay, now, how can we remedy some undercoverage? Okay, some undercoverage can't be remedied, but we can definitely remedy some of it overall. And how we do that is we can separate the population based on common characteristics. Okay, so if there are specific groups that we're concerned about, and those groups have common characteristics, we want to separate the population into those groups first before we do our random selection. Now, once we have separated them, then we would do our random selection. And we just have to be careful of terminology here. If this is a survey situation, we want to use the term stratifying. Okay, so we're stratifying the groups for a survey. The proper term in an experimental setting is called blocking. We're blocking them based on those common characteristics: male, female, age, ethnicity. There are a number of situations where we can stratify or block because it's an important characteristic, and it has to be common of the individuals overall. Now, when we talk about experiments, okay, what are the principles of experimental design? Okay, we want to understand and know the three main principles. Sometimes there's a fourth, but the fourth kind of comes into the idea of what an experiment is in the definition. Okay, so when we look at the three main principles, number one, randomization. We have to have a random selection process in experimental design. We need to have a control group. The fourth piece comes in with the control, and it's talking about a comparison. Okay, so if you have a control group, you're going to have comparison naturally, so we don't have to have a fourth principle. And then the last one is replication. We really want to be careful here. Replication does not mean doing the experiment multiple times, but what it does mean is we have enough subjects or enough experimental units so the differences that we see between the treatment and the control group are not based on chance alone. Okay, other important experimental terms that you want to know and be able to use, we've got factors, the things that are being manipulated in the experiment. We've got the levels. There can be different amounts of each factor that we would have. And when we finish this up, the factors and the levels multiply together to give us the number of treatments in that experimental setting. Okay, one last term that we do also want to add in here is the idea of a confounding variable. Okay, a confounding variable is a bias term, and it is an outside factor that is actually causing some of the effect that you see in this situation. Okay, so that is our main run through the important terms of survey and experimental design. Thanks and have a good day.